Good afternoon. Welcome back to Math 096. Last class we discussed function notation. We talked about how to input values. So your input, output, you're thinking of x as your independent variable, your input, and you thought about y as your dependent variable, your output. We also talked about domain and range, and we talked about determining whether or not a relation is a function. Visually, we can determine that by using the vertical line test, or we can simply look and analyze the relation, the set of ordered pairs, and as long as x does not repeat as a value in any of your x coordinates repeat, then you do in fact have a function. If your x coordinates repeat in your relation, then it is not a function. So that's essentially a recap of everything that we covered last time. What we're going into today is we're going to continue with this idea of function notation and evaluating given certain values, but also interpreting what that means in terms of real-world applications. So we're finally ready to look at example real-world problems and understand how the math pertains to that real-world application. So let's take a look and see how it goes. Brian is out of town. He currently has 150 unread emails. I always like to underline pieces of information. That way it is helpful to myself as I dissect the formula and all of the information that we're given in terms of the variables. So he currently has 150 unread emails in his account, and the number is expected to grow by 20 emails per day. So this is interesting. The function n of t is equal to 150 plus 20t. So this is interesting. The 150 I notice in my function, it says here there were 150 unread emails. So those two match up. And then I also notice that it's expected to grow by 20 emails per day. And I see here 20t. So this 20 represents the growth of 20 emails per day. So that's interesting. We're going to think about that as we continue. So that function represents the relation between the number of emails n and the time t measured in days. That's very important. So what I want you to recall is the slope-intercept form, y equals mx plus b. And then what I'm actually going to do is I'm going to rewrite the function directly underneath it because I want you to see the relationship between what we've learned so far and function notation in this context. So we have n of t. Now notice I have 150 plus 20t. If I rewrote this in descending order, I would hope you'd all agree with me that this is 20t plus 150. So these two functions say exactly the same. 150 plus 20t. I've written it directly underneath our slope-intercept form so that you can see the connection. You can see that m is 20. You can see that b is 150. So what that implies is that my slope is 20 and my y-intercept is 150 or 0, 150. So these are some things to think about. Okay. Next, we want to determine the independent and dependent variables. We learned last time that our input is represented by our x value. So input is also representative of the independent variable. So I'm going to write a reminder that x is our input and our input is our independent variable, where y is our output, and that represents our dependent variable. It's always good to kind of have that in the back of our minds as we dissect this. So if we note that x is the input, it's our independent variable, well, in our function, x is replaced by t. So t is the input or the independent variable. So I'm going to write here that t, which is time in days, is the independent variable. Okay, I abbreviated a little bit. I hope you don't mind. So t, time in days, is the independent variable. I also hope that makes sense. Time should be independent always. Can you stop time? Can you speed up time? Can you reverse time? No. I mean, I wish, right? Sometimes I wish I could go back in time, but we can't. So because we cannot impact or influence time, it makes sense that time would always be considered our independent variable. So if you ever had to choose and time is one of your variables, you know that that's definitely the independent variable. If we say that t is the independent variable, then we know that n, the number of emails, is the dependent variable. So n, number of emails, is the dependent variable. So essentially, the number of emails depends on the number of days, right? The number of emails depends on the number of days. Good. Now let's take a look at part B. Part B says find n of 7 and then explain what that result means. So I'm going to write n of 7 is equal to, and as we learned last class, essentially our variable that's within the parentheses, so in this case it's t, because t is being replaced by 7, that means any t's in the equation will also be replaced by 7. So we're going to write 20 times 7 plus 150. If it's helpful, directly above I can write the original function just so you can see. N of t is equal to 20t plus 150. If this t gets replaced by 7, then you better replace the other t. Otherwise, what's the point? So n of 7 is equal to 20 times 7 plus 150. If we do the math, make sure you follow the order of operations. 20 times 7 is 140 plus 150. That's n of 7. And let's finish this off. So n of 7 is equal to 290. So we found n of 7. Awesome. But now we have to explain what this result means. What I want you to recall is that this represents an ordered pair. Our ordered pair in this case, because x is t and y is n, consider the following. Let's write our ordered pair. We know that x is t and y is n of t. That's the interpretation. That's the relationship between x and t and y and n of t. So these line up. Now, when t was 7, we found that n of t is 290. We know that t represents the time in days, and we know that n of t represents the number of emails. Okay, so let's write out the statement that pertains to this ordered pair. Okay, so we are going to write, after 7 days, the number of emails in Brian's account is 290. After 7 days, the number of emails in Brian's account is 290. Consider that Brian is out of town. He had 150 starting off, but for every day he's gone, it's going to increase by 20 emails. So think about that logically. After 7 days, he had an extra 140 emails on top of the 150 that he already had. So the number of emails in his account will be 290. And that's what that ordered pair implies. Good. Let's take a look at number 6. Javier has $550 in his savings account. Each month, $12 is automatically withdrawn from his account for his Netflix subscription. The function b of t is equal to 550 minus 12t represents the relation between balance in his savings account, b, and the time t measured in months. And that should make sense. You are charged monthly for your streaming subscription, Netflix, Hulu, HBO Now, Disney Plus, whatever it is, unless you do the year plan. So if you do a monthly plan, you're charged every single month. Again, what might be helpful is let's write out y equals mx plus b, and then directly underneath this, I'm going to write the given function, but I'm going to write this in descending order. So the negative 12t will come before the 550, so negative 12t plus 550. Now we've written the function in descending order. That may be helpful. So now we want to determine the independent and dependent variable. So our independent variable will always be our x, our input. X is being replaced by t, and t is measured in months. So the independent variable is t, and that is time in months. Next, we want to define the dependent variable. The dependent variable is y. Y is our output, our dependent variable, and that is represented by b. And b is the balance in his savings account. So balance in savings. So essentially, Javier has $550 in that account, and he's using that strictly for Netflix. So $12 is going to be subtracted from his account over time, monthly, until he obviously runs out of money in his account. But that should make sense. Part B asks us to find b of 12. So the function at value t equals 12. So let's check it out. So if it's helpful, I'm going to rewrite the formula. And then I'm going to write b of 12 directly underneath it. Notice here that t is being replaced by 12, so any t in the formula should also be replaced by 12. We are trying to evaluate the function at the value 12. So let's check this out. We're going to go ahead and do our math. So negative 12 times 12 is a negative 144. So we have a negative 144 plus 550. That'll give us 406. So b of 12 is equal to 406. In this case, recall that x and y are being replaced by t and b of t, where t represents time in months and b represents the balance in savings. And we have t as 12 and b of t is 406. So it's always helpful to kind of rewrite that information. Once you have it written as an ordered pair, it's a lot easier to discern what's happening here. So t is 12 and b is 406. So what this means is that after 12 months, Javier will have $406 remaining in his savings account. You could have said that as the remaining balance in Javier's savings account is 406. That would be exactly the same thing. So if you had a statement here that differs a little bit, that's totally okay, as long as the idea is after 12 months, Javier has 406 in his savings account. Excellent. Let's turn the page. A cell phone company has a text messaging plan that charges $5.50 per month plus 6 cents for each text message sent. We want to write C, the cost per month, as a function of N, the number of text messages sent in a month. So the first thing I'm going to consider is, let's write down what we have or what we know. C is the cost per month, and we know that N is the number of text messages. When you think of it this way, doesn't the cost depend on the number of text messages sent? If the cost depends on the number of text messages sent, then our XY is actually represented by NC. The cost per month depends on the number of text messages that you send. So NC C is our ordered pair. For part A, we want to write down the formula. So we know that C is a function with respect to n. So C of n, our input is n, C of n equals. Now, we know that we're charged $5.50 per month plus 6 cents for each text message sent, where n is the number of text messages. So what I would urge you to do is think about this very logically. You're going to be charged $5.50 no matter what, plus 6 cents for each text message. Hopefully that was clear. We use word-for-word interpretation. $5.50 per month plus 6 cents for each text message sent. You may be thinking, but what about the number of months? Take a look at the language in part A. Write C, the cost per month, as a function of n, the number of text messages sent in a month. So we're not worried about how many months we're referring to. We want to look at that singular month. What's the function that is being used to determine the cost for that month as it pertains to the number of text messages sent? So part A is done. Next, part B says, what would the bill be if one sent 2,543 text messages in a month? Recall that C is a cost per month and N is the number of text messages. Well, if you're given 2,543 text messages, don't you agree that that has to be representative of N? So I'm going to write here that we are told N equals 2543. So N equals 2,543 text messages or texts. So now we need to actually evaluate the cost. So we have the cost of 2,543 text messages is found by taking 0.06 and multiplying it by 2,543 and then adding to that the 550. The 550 is the base cost, and you have to add to it 6 cents for every text message you sent. So if we take our calculators and we punch in 0.06 times 2543, we'll get 152.58. But we still have to add on the 550. So let's finish this problem by adding on the 550. So our cost is $158.08. Okay? That is the cost for that particular month if someone were to send 2,543 text messages. That's pretty hefty. For part C, we know that Joe's bill last month was $106.42. How many text messages did he send? What I want you all to get used to is that when we are discussing linear functions like this, and we have two unknowns, C or N or C, then if you know one of the values, you have to find the other, right? It's as simple as that. There are two unknowns in this case. If I give you one of those, you'll be able to find the other. So consider here that we were told the cost, which is 106.42. So in our function, our cost is going to be replaced by 106.42. So where it says C of n, that entire thing gets replaced by 106.42. And what we'll be responsible for is finding n, the number of text messages sent. Notice the equation stayed exactly the same, with the exception that we replaced our C of n, our cost, with the given information. Now all we have to do is solve. So I'm going to subtract the 550. So we have 106.42 minus 550. And that gives us, let me draw this line here. That gives us 100.92. is equal to 0.06n. And now let's divide both sides by 0.06. If we divide both sides by 0.06, we get that n is equal to 1,682. So we can say 1,682 text messages. And there you have it. So we started off with our function. Based on the language of the word problem, we carefully dissected this. We noted that for our ordered pair xy, we were actually referencing n and c. You could even take it a step further and say n and c of n, right? C as a cost, as a function of n, the number of text messages. And then we had two parts where we were playing around with this, if I give you one, you give me the other, right? So if I give you the number of text messages, you can tell me the cost. If I give you the cost, you can tell me the number of text messages. It's as simple as that. If you know one, calculate the other. So what I'd like to do is only give you 2 minutes to try number 8. So I'm going to read that to you first, and then I want you to have just 2 minutes to give this a shot on your own. A savings account is opened with a $50 deposit. Each week, an additional $25 is deposited. You're going to write B, the weekly balance, as a function of D, the number of deposits made. And then you will tell me what the balance is after 20 weeks. And then you'll note that if Keisha's balance is $825, how many weeks has it been since she opened the account? 2 minutes starting now. All right, so let's take a look at how you did. So we have an answer coming in. Let's check it out. So write B, the weekly balance, is a function of D, the number of deposits made. Again, I want you to note that B is the weekly balance. And also notice that D is the number of deposits. I also want you to note that the weekly balance depends on the number of deposits, doesn't it? So I want you to consider that for this particular function, our x and our y are actually being replaced by D and then B of D. So D, the number of deposits, will indicate what that weekly balance is. So the weekly balance depends on the number of deposits. So Brittany, I see your answers. Let's see if they're correct. For part A, we want to write B of D, so we want to write the function. We notice that we started with $50 deposit. Each week, an additional $25 is deposited each week. So it's going to be 25D, right? D being the number of deposits. So $25 for each deposit each week, right? Plus the $50 from where we started. Excellent job, Brittany. That is perfect. Next, what will the balance be after 20 weeks? Okay, as a reminder, B is the weekly balance, so we don't know what the balance is. It says, what will the balance be after 20 weeks? And I want you, let's make a correction here. D is the number of deposits, but I want to say D is the number of weekly deposits. Let's make that correction here, just so that it's clear. D is the number of weekly deposits. So we know that we need to find balance after 20 weeks. So we want to find the balance after 20 weeks. So we are going to replace D with 20. We're going to go ahead and do this math. So 25 times 20 is 500. So 500 plus 50. And then what you want to do here is combine like terms. So we have B of 20 is equal to 550. So what we can say is the balance after 20 weeks, or after 20 weekly deposits, is $550. I wanted you to see an example of using this kind of language in your interpretation so that you see how I'm using B and D in terms of my sentence, in terms of how I describe that particular ordered pair. Part C states that if Keisha's balance is $825, how many weeks has it been since she opened the account? So what we are given here is we know what the balance is. We know what B of D is, and that is 825. So you're going to replace B of D with 825. And what we'll do is we will then solve for D, the number of weekly deposits. We're going to subtract 50 from both sides. So that is 775 is equal to 25D. And then we are going to take the 775 and divide by 25. So if I divide both sides by 25, I get 31. So we can say there have been 30, or there has been, excuse me, my language, my grammar. There has been 31 weekly deposits in Keisha's account. Perfect. And I apologize for this right here. There has been 31 weekly deposits in Keisha's account. And that concludes number 8. Brittany, that was perfect. Nice job on that work. Let's turn the page. What I want to do right now is to take a moment to recall what slope means. So we know that slope measures the rate of change. Now, as we think about rate of change, I want you to consider the formula for slope. So as a reminder, we know that slope, which is m in our y equals mx plus b form, in our y equals mx plus b slope-intercept formula, we know that slope is the same as the change in y over the change in x. Okay? Think about it as the change in our dependent variable divided by the change in our independent variable. So I'm going to say the change in y over the change in x. We're going to use this idea in terms of interpreting real-world problems, and you'll see that in a bit. Next, I want you to recall that the y-intercept is where the line crosses the y-axis, or the value of y when x is 0. So the y-intercept will always be represented as 0, comma, the number. Recall that in y equals mx plus b, m is our slope, and this b part is our y-intercept. That's going to be useful as we dissect the following problems. Okay? Let's take a look. The relationship between predicted test scores, y hat, like somebody put a hat on someone, so y hat, and hours of study x is analyzed. So predicted test scores, y hat, hours of study, x. Always identify your variables first. If you don't, you're up for a world of trouble. Okay? Always identify the meaning of your variables first. Know x and y. We know that x is your input, your independent variable. So I'm going to write independent. And your y is your output or your dependent variable. So I'm going to put that right on top. Just so we have an idea. A statistician determines the relationship can be explained for students that study between 0 and 8 hours using the following equation. Y hat is equal to 55 plus 7.5x. So again, if it's helpful, I'm just going to rewrite the formula in slope-intercept form, meaning in descending order. So we have 55 plus 7.5x, which can be rewritten as 7.5x plus 55. I'm only rewriting it so that you all can see the relationship between slope-intercept form and the actual slope-intercept form here when it's written in descending order, when they line up like this, okay? So we want to identify and interpret the slope. Notice if we consider this being slope-intercept form, which we should, by the way, it is in slope-intercept form, y equals mx plus b, we note that m is 7.5, and we know that b is 55. M represents slope, so I'm going to note that slope is 7.5. Now we have to think about what that actually means. So in terms of interpreting slope, I'm going to go back to this idea of slope being the change in y over the change in x. Y is the predicted test score, and x is the hours of study. Okay, we're going to think about that. Now I want you to write 7.5 over a 1, because usually when we interpret slope, we always write it as a fraction, numerator and denominator. And if there is no denominator written, we know that we can place it over a 1. So now let's take it a step further and interpret what this means. What may help is the following. We know that the numerator of our slope is the change in y, right? And the change in y in this case refers to the predicted test scores. So what I'd like to do here is I like to write predicted test score, right? And then the 1 in my denominator represents the change in x, and x in this case represents the hour of study, the hours of study. So hours of study. Now, carefully look at what this is saying. 7.5, predicted test score, 1 hour of study. We know slope is positive in this case, so we have a positive rate of change in y over change in x. So here's a statement that this refers to. For every increase in hour of study, or in hours of study, there is a predicted test score increase of 7.5 points. Oops, I'm so sorry. For every increase in hours of study, there is a predicted test score increase of 7.5 points. You could have said, for every extra hour of study, the student can expect to earn 7.5 additional points. You could say it like that. You can say, for every hour of study, you can predict that the student will get an extra 7.5 points. Any of those will work. I'm hopeful that by writing out the actual description next to the numerator, next to the denominator, that it gave us a jumping off point where we can say, hold on, how does all of this come together? They're both positive. We know slope is rise over run. We know this is a rate of change. They're both positive numbers. Again, thinking about that and saying, oh, okay, I got it. Input, output. The input is the hours of study. So for every increase in hours of study, so for every 1 hour you increase, you're predicted to increase by 7.5 points. Good. Let's take a look at B. B says identify and interpret the Y-intercept. So we've already noted that B is 55. That's incredibly helpful. The Y-intercept in this case, Y-intercept, is 0, 55. We also want to note that in this case, x is 0, y is 55. let's go back to what x is. X is the hours of study, and y is the predicted test score. Do you see how I literally match up? 0 is x, x is hour of studies. 55 is y, y is the predicted test score. So what this says is, if a student studies for 0 hours, they are predicted to earn a test score of 55. You can say if the student doesn't study at all, it is predicted that that student will earn a 55. And that's according to this formula. Obviously, this formula was based on statistics that the statistician collected. And we're using that to predict what the test scores are for this particular test. This is not just for any test, it's for a particular test. Okay, let's take a look at part C. Part C says predict the test score for a student who studies 3 hours. Just like before, we have our formula, y hat is equal to 7.5x plus 55. We are asked to predict the test score. We know that predicting the test score is represented by y hat. And if we're told that the student studies for 3 hours, we know that the hours of study is represented by x. Notice how I underline this phrase and I write y hat above it. I underline studies 3 hours and I wrote x above it because we know the value that we're given is exactly x. It's our hours of study. So we need to calculate y hat. So we have y hat is equal to 7.5 times, and then x is going to be replaced by 3 because we were told that this particular student studied for 3 hours. So we're going to go ahead and do this math. 7.5 times 3 is 22.5. And then we're going to add 55 to that. And we find that y hat is 77.5. So a student who studies for 3 hours is expected to earn a 77.5 as a test score. If you have room, go ahead and write that down. I'm going to squeeze it in. If a student studies for 3 hours, they are predicted to earn a 77.5. Okay. If a student studies for 3 hours, they are predicted to earn a 77.5. Lastly, part D says, how many hours does a student need to study for a predicted score of 85? So again, how many hours? We don't know that, but we do know that x represents the hours of study. So how many hours does a student need to study for a predicted score of 85? Your predicted score pertains to y hat. So if I were to rewrite the formula, y hat is equal to 7.5x plus 55, this time we know what the score is. What we don't know is how long that student studied. So we're going to replace y hat with 85, which means we need to solve for x. I'm going to go ahead and subtract 55 from both sides. That'll leave me with 30 is equal to 7.5x. I'm going to take the 30 and I'm going to divide it by 7.5. If we divide both sides by 7.5, we get that x is 4. It is estimated, or predicted, whatever you'd like, it is estimated that to earn an 85, the student must study for 4 hours. It is estimated that to earn an 85, the student must study for 4 hours. Good. Hopefully that was helpful in terms of how we broke everything down and the fact that as we read through each of the parts, we identify the information we're given and then we make note of what it is that we're trying to solve for, what we're trying to find. So let's turn the page. The relationship between predicted hot chocolate sales in dollars at Mendenville Ski Resort Y hat and outside temperature in degrees Fahrenheit X is analyzed. A statistician determines the relationship can be explained for temperatures between -5 degrees Fahrenheit and 40 degrees Fahrenheit. Your formula is Y hat is equal to 393.7 minus 7.18x. What I would urge you to do is write it in descending order so that it's clear what you are looking at. So that when you think of slope-intercept form, you know what the slope is, you know what the y-intercept is. Take 2 minutes to work through the 4 parts of this problem, starting now. Okay, let's see how you did. So if you followed a similar format to what we use for example 9, what you started off by doing is noting what y hat and what x represent. So notice that predicted hot chocolate sales in dollars at the resort is y hat. So predicted hot chocolate sales at that resort is y hat. The outside temperature in degrees Fahrenheit is x, so I'm going to underline that as well. Okay, input, output. Next, we want to identify and interpret the slope. So for part A, according to our formula, which is in slope-intercept form, we know that the slope is negative 7.18. So slope is a negative 7.18. I'm going to write this over a 1. Okay. Whenever we don't see that denominator, we know that we can simply write in a 1. So let's take a look. Excellent, Michelle. I see some answers coming in. Let's see how they compare to my work. Recall that slope is the rate of change. We also recall that in terms of slope, we're either rising or falling, or, rising over run or falling over run. Now, we also want to note that the numerator is the change in y, the denominator is the change in x. So, if the numerator is the change in y, so essentially this refers to the predicted hot chocolate sales. So, predicted hot chocolate sales, where the 1 in the denominator represents the change in x, and x is the outside temperature in degrees. So outside temp in degrees Fahrenheit. Okay? Now we have to think about this relationship. There's a 1 here, a positive 1, outside temperature in degrees Fahrenheit. And then we notice here negative 7.18 is predicted hot chocolate sales. So putting those ideas together, here's what this says. For every increase in 1 degree Fahrenheit, it is predicted that the hot chocolate sales will decrease by $7.18. For every increase in 1 degree Fahrenheit, it is predicted that the hot chocolate sales will decrease by $7.18. So what this sounds like is that as it gets warmer, less people are buying hot chocolate. But as it gets colder, more people are buying hot chocolate. I always think about, like, Penn State games. Like, I've been to a couple Penn State games, and those are a lot of fun. And the times that I've gone, it's been really, really cold. And one of the things that I noticed as a newbie going to a Penn State game is that everybody's buying hot chocolate. It was the funniest thing. I'm like, okay, everybody's buying hot chocolate at a Penn State game. But I noticed out of the two games that I went to, the first one was freaking freezing. It was so cold. It was insane. And everybody had hot chocolate because it was so piping hot and delicious and yummy. The second game that I went to was beautiful and sunny, and almost nobody bought hot chocolate. So that should make sense in terms of this word problem. The warmer it is, the less hot chocolate you're going to sell. The colder it is, the more hot chocolate you'll sell. So hopefully that slope makes sense. Part B, identify and interpret the y-intercept. We know that slope was a negative 7.18, and we also know the y-intercept is 393.7. But as an ordered pair, the y-intercept will be written 0, 393.7. So let's talk about what that means. X represents the outside temperature in degrees Fahrenheit. Y represents the predicted hot chocolate sales. Temperature, sales. Okay, here's my statement. When it is 0 degrees Fahrenheit, it is predicted that the resort will sell $393.70 worth of hot chocolate. When it's 0 degrees outside, that particular resort is expected to sell $393.70 worth of hot chocolate. Next, for part C, we want to predict the hot chocolate sales on a 25-degree Fahrenheit day. Okay. If we want to predict the hot chocolate sales, that means we don't know y hat. So predict, that's y hat. We don't know what that is. On a 25-degree day, we know that x pertains to x pertains to the temperature. So we have y hat is equal to negative 7.18. And I hope you don't mind, I'm simply going to replace the x with a 25 since we know what the temperature is. And we're going to go ahead and punch this in. So we have negative 7.18 times 25. That gives us negative 179.5 plus 393.7. Let's add the 393.7 to the negative 179.5, and we find that y hat is 214.2. So when it is a 25-degree Fahrenheit day, the resort is predicted to sell $214.20 worth of hot chocolate. James, I see your answer coming in. You had the 214.2. Very nice. Let's take a look at your answer for part D and see if it agrees with my work. For part D, it says, what is the temperature? If it says what is the temperature, that means we don't know x. If the predicted sales is $350 and 62. So the predicted sales is $350.62. So take your original equation, replace y hat with 350.62 and solve for x. So we have 350.62 is equal to negative 7.18x plus 393.7. Let's subtract 393.7. Okay, we have 350.62. Go ahead and punch this into your calculators. Minus 393.7. That gives me a negative 43.08 is equal to negative 7.18x. Now we're going to divide both sides by negative 7.18. So James, excellent job. Your answer was perfect. We divide both sides by negative 7.18 and we get x is equal to 6. So you were correct. When it is 6 degrees Fahrenheit, the resort is predicted to sell $350.62 worth, can't believe I wrote worth of hot chocolate. Good. Beautiful. And that takes care of example 10. Okay, let's take a look at measures of center. So measures of central tendency are numeric values used to locate the center of a set of data, right? It's like measures of central tendency, tending towards the center. So we have something called the mean, which I'm sure a lot of you are actually familiar with. The mean is our average. Average represents the mean. We actually have two separate notations pertaining to whether or not we're working with a sample or a population. So if we are working with a sample, our mean is represented by x bar. X bar is the mean, is the average. So either way, these notations here, they both represent the mean. They both represent the average, the arithmetic average. So in order to find the mean or the average, you're going to take all of your data values and you're going to add them together. This summation here, this sigma, means you're going to add all your x values together. Once we add all of our raw data values together, you're then going to divide by the number of values that you have, right? That's what n represents, the number of values in our sample. Similarly, we have a formula for finding the average or the mean for a population. This is for a population. Notice that it's the same idea. You add up all your raw data values and then you divide by the total number of values in the population, in this case, capital N. So with a sample, you have x bar, which represents the mean, and is the number of values in the sample. For a population, you have something called mu, Greek symbol mu, right? Greek letter mu, like mu. So mu represents the mean, the average, and you add up all your values and you divide by the number of values in the population. Perfect. We know how to find the mean. Let's actually do that. So for example number 1, we want to note the mean for the following sample. So it's a sample, which means we're finding x bar. We want to add all of our values, 10 plus 20 plus 30 plus 40 plus 50. And we want to divide by the number of values we have in this sample. We have 1, 2, 3, 4, 5 values in our sample. So if we take our numerator and combine all of our values, notice we have 60 here, we have 60 here, that's 120, 120, and 30 is 150. So we have 150 divided by 5. When you take 150 and you divide it by 5, you're going to get 30. So your average for this particular sample is 30. Now let's do that again, except this time we're going to take our last value and blow it up. I want to illustrate to you what happens when you have outliers, when you have values that are so much larger or so much smaller than the rest of our values. So this is called an outlier. Okay, so I want to show you what happens to the mean when you have something like this in your data set. So x bar is going to be the sum of all of these values. So we have 10 plus 20 plus 30 plus 40 plus 500. And we're going to divide by 1, 2, 3, 4, 5. We still have 5 values. So again, in my mind, I'm going to do 10 plus 40, that's 50, 20 and 30, that's another 50, 50 and 50 is 100, 100 plus 500 is 600. So we have 600 over 5. If you take 600 and you divide it by 5, you get 120. What happened? Look at how much the mean is impacted by outliers. When you had 10, 20, 30, 40, 50, your mean, it was reasonable. It was the center of the data, 30. But when we had such a large outlier, this 500, notice the mean was pulled closer to that 500 than all of our other values. So what we can say is our mean is greatly impacted. Oh, thank you, Brittany. I actually should have paid attention to the fact that we're referring to the population. So let me replace x bar with mu. So that was my bad. Sorry about that. See how important it is to read the word problem? Consider our value won't change. We should just use the correct notation. So in this case, we're using mu for the mean of the population. Thank you, Brittany, for pointing that out. So our mean is greatly influenced by outliers, either significantly, oh my God, I can't spell. There we go. Either significantly smaller or larger values as compared to the rest of the data. Okay, our mean is our mean is greatly influenced by outliers. Outliers are either significantly smaller or larger values as compared to the rest of the data. So our mean is greatly influenced by outliers and is pulled in the direction of the outlier. So let's turn the page. Now let's look at our next measure of central tendency, the median. So the median is the middle value of a data set when the data is ranked numerically from lowest to highest. The median of a sample is denoted by x tilde. Like if you think about Spanish and Ñ, right? Like Munoz, for example, as a last name, that N with the tilde, same idea here. This is x tilde. The squiggly line is tilde. The population mean, capital M, or uppercase mu, is the data value in the middle position of the entire population. So for a sample, we're going to use x tilde. For a population, we're going to use capital M. Now, to find the median, it's as simple as this. First, rank the data. Rank it from lowest to highest. And then find the exact middle of the data. If you have two values that are in the middle, you are essentially going to average those two out. If you have one value in the center of your data, that is your median, and you don't even have to worry about anything else. So I've provided that information to you here so that you can easily say, oh, okay, if I have an odd number of data values in my set, the median is going to be the exact middle. You don't have to worry about averaging. If it's even, you're going to end up having to average the two middle values. So let's take a look at our first example. What is the median of the sample 20, 30, 40, 50? Now, to find the median, you have to rank the data from low to high. Luckily for us, that's been done. Next, to find the median, we want to identify the exact middle value. So 10 and 50, those are on the outside. Next, 20, 40, and then the exact middle we find is 30. So it's the median of the sample, the median, x tilde, is 30. Now let's look at part B. Notice the values in part B, 10, 20, 30, 40, 500. So just like with our previous problem when we were discussing mean, we replace the last value with 500, something that's significantly larger than the rest of our data, an outlier. Now I still want to determine the median of this sample. So I want you to notice that these are on the outside, these values go away, these values go away, and we still have a median of 30. Notice that regardless of whether or not this value is 50, 500, 5,000, 5 million, whatever it is, it has no impact on identifying the exact middle of a set of values. So what happened to the median when the 50 was replaced with 500? Nothing happened. As it was not influenced by the outlier. It simply was not influenced by the outlier. To find the median, you arrange your values from lowest to highest, and then you find the exact middle. And it doesn't matter if that highest value is extremely high, and it doesn't matter if that lowest value is extremely low. You're still identifying the exact middle of the set of data. So the median is not impacted by any outliers. So part D says, what is the median of this sample? So we have 60, 20, 10, 50, 40, 30. I'm going to give you 1 minute. Find the median of this sample, starting now. All right, let's take a look. First things first, arrange your values from low to high. So we have 10, 20, 30, 40, 50, 60. We're then going to cancel the edges out essentially until we find the middle. Notice that these go away, and you have two values in the center. No big deal. You are then going to average the two values here. So you're going to take the 30, add it to the 40, and then divide it by 2. 30 plus 40 is 70. Divide that by 2. And Brittany, you are correct. You said 35 is our median for the sample. Nice job. Let's turn the page. For example number 3, we want to find the mean and median for the following samples. Make sure you use the proper notation. So for the sample, for mean, we have x bar. For the median, we have x tilde. And then, of course, round to the nearest tenth when necessary. What I'd like you all to do is, on your own, give these a shot. Make sure that you can find the mean and the median for each of these. What I will do is I will give you the solutions to these via email so that over the weekend, when you're doing these, you can verify that your work is correct. So for now, I'll make a note, do at home. You don't need to email me your results. I will verify with you when you read your email and check the answer key that I give you. But let's do one more problem for the day, and that is example 4. A mean grade of 73 or higher, I'm going to make a note of that, 73 or higher, it's a mean grade, is required to pass Professor Smith's class. If there are 5 equally weighted exams in the course, what is the minimum grade one would need to earn a C if their first 4 exam grades are 80, 65, 78, and 58. And wow, there are typos in this, so I'm going to have to retype this up. Okay, so let's check it out. We know that we want a mean grade of 73 or higher. We know what the scores are for the first 4 tests. So essentially what we're doing here is we're going to average all 5 tests. We just don't know what the 5th one is. So think about it like this. We want to find the average. So we need to take the 80, the 65, the 78, and the 58, add those together, but I want you to consider we also have a 5th test. We don't know the value of that 5th test. What we do know is that the average of all 5 need to be 73 or higher. So the average, which is represented here, must be greater than or equal to 73. That's the score we need. This is our cutoff, so it must be 73 or higher. So at this point, all we have to do is solve. So we must first combine like terms. 80 plus 65 plus 78 plus 58. That gives us 281 plus x. Notice we have plus x, don't drop that, over 5 is greater than or equal to 73. Notice we have a fraction here. So recall from Unit 2, whenever we had fractions in our equations, we always multiplied by the LCD to eliminate fractions. So I would urge you to multiply both sides by 5. When we multiply both sides by 5, these 5s are going to cancel. Since they cancel each other out, you're left with 281 plus x is greater than or equal to, and then we do 73 times 5. 73 times 5 is 365. And Brittany, you're saying 84. Let's check it out. We then subtract 281 from both sides. And 365 minus 281 gives us exactly that, 84. So the student must earn an 84% or higher to earn a C grade. Okay? Excellent job. Hopefully all of that made sense. I really hope that you work on your example 3 to make sure that you're getting the same answers that I'm getting. As I said, I will send you an email with those answers so that you can verify that you're doing the work correctly. Other than that, wonderful job today. We will pick up where we left off on Tuesday, and we will finish our notes on Tuesday. So that will be our last YouTube class. All right, everyone? Have a fantastic weekend. Please stay safe. Please stay healthy. And I'll see you then. Bye, everyone.